Okay, everyone, it's Ms. Martins, and I'm going to continue the lesson where we left off. So just to review, the triangle sum theorem states that the three angles in any triangle will add to 180 degrees. So as we saw in class, okay, we were able to use that fact here. And we saw that this was 85 degrees. This is its vertical angle, so it must also be 85. We can use the triangle sum theorem, knowing that these add to 180. Well, I have 85 plus 70. I think that's going to get me about 155 degrees total. I'm going to subtract that from 180 to figure out what's left over and belongs in this angle right over here. Well, 180 minus 155, 70, borrow from 10. I think we're going to get about 25 degrees. So I know that this is 25 degrees, and that helps me figure out the angle right next to it because they must be supplements. So I do 180 minus 25, and I think I'm going to get 155 degrees here. And that would be my final answer. Okay, coming over here, we can use a similar process. We know that 120 is going to be supplementary with this angle here. So that means this has to be 60 degrees. Same thing over here, we have 150 and its supplement, leaving 30 to get to 180. I'm just doing some mental math. Now that I have these two interior angles of my triangle, I can use the 180 rule to figure out what's left. Well, 30 plus 60 is 90. I need another 90 to get to 180. And here's my 90 degrees. Okay? And that's my final answer. So, continuing on. Bear with me. The exterior angle theorem. Well, the exterior angle theorem states that if you have an exterior angle of a triangle, which we'll call x, okay, it's going to be equal to the sum of the two remote interior angles, which are right here. Okay? So if we call this A and B, we know that x is going to equal the sum of A plus B. So let's see what that would look like in a problem. Okay? We have 118. That's our exterior angle, and I'm going to label that exterior. And here are my two remote interior angles. Okay? If I add these up, they're going to equal 118. So I can just basically state that. 13x plus 1 plus 9x plus 11. Excuse me, not 11, plus 7, okay, is going to equal 118 degrees. Okay, combine my like terms. 13 plus 9, I think that's going to get me 22 x's. Combine my like terms here, and I think that's going to get me plus 8, and that equals 118. Okay, we're going to subtract 8, subtract 8. I'm going to get 22x equals 110. Okay, divide by 22. I'm sorry, yep, 22. And then I get x equals 5. Okay, but remember the question didn't just ask for the value of x, it asked for the measure of angle E. So I've got to go find E, plug in 5, I get 9 times 5 plus 7. Scoot that over a little so you can see. I think we're going to get 45 plus 7. Well, I think that's going to get us 52 degrees. Okay, so same thing for 30. Okay, you've got two remote interior angles and you've got an exterior angle. Another way you could do this if you want is you could figure out the supplement to this, subtract from 180, find this angle measure inside here, right? And then this plus this plus this equals 180. So you have two ways of doing that here. You can use the exterior angle theorem, where the exterior angle is equal to the sum of the remote interior angles, okay? Or you could use the triangle sum theorem, knowing that these two are supplements. So you've got a little bit of choice here, okay? Continuing on, the isosceles triangles main idea. Basically what you want to know is that the base angles, you're gonna have to forgive me for the little overlap, the base angles are congruent, okay, in isosceles triangles. Okay, so to find the value of x, well, first I have to figure out where the base angles are. They're always across from the two congruent sides. Okay, the two congruent sides meet at the vertex angle, so this here is the vertex, and these are your two congruent base angles. Okay, they are across from the two congruent sides. So if this is 69, that means this also has to be 69 degrees. Okay, and then I can use the triangle sum theorem, 69 plus 69, okay? That's like 70 plus 70 being 140 and then subtracting 2. So I'm going to get 138 degrees for the sum. Subtract from 180, and I think you're going to get 42 for x. And we're putting that in view. Okay, same thing for 32, okay? 50 would be the vertex angle, because that's where the two congruent sides meet. Okay, and if this is x, it has to be congruent to its base angle, which means this is also x. Okay, so in other words, these two are equal. So basically how you can tackle this is by setting up an equation where x plus 50 equals 180. Or you could think of this as subtracting 50 from 180. I think you're going to get 130. And then taking the remaining degrees and splitting them evenly between these two angles. So you could do 130 divided by 2. I think that's going to get you about 65 degrees each. Okay, so whether you do an algebraic equation or whether you just think through it logically, knowing that you only have 130 after you take away the 50 from the vertex angle, doesn't really matter. Okay, so flipping on to the next page. Okay, we have the triangle inequality theorem. Basically, if you take the two smallest sides and you add them together, add the two smallest sides, and the sum needs to be bigger than the biggest side. Sum should be bigger than the biggest side. And if that's not true, then the triangle is impossible. Okay, so state if the three numbers can be the measures of the sides of a triangle. Well, if I look at number 33, 6 and 12 would be the two smallest sides. I'm going to add them up. 6 plus 12 is 18. Okay, and I want to check to see if 18, the sum, is bigger than the biggest side. Well, 18 equals 18. It's not bigger. So therefore, this is impossible. Okay, heading over here to 34, I'm going to find my two smallest sides. I get to pick either 10. Doesn't matter which 10 I pick. 6 plus 10 is 16, and I want to check to make sure that this sum is bigger than the biggest side. The sum is bigger, 16 is bigger than 10, so yes, it's possible. Okay, for the range of possible values, just add to find the upper boundary and subtract to find the lower. Okay, so here we have 8 and 7. To find the upper boundary, we're going to add. So 8 plus 7 is 15. And when we subtract, we'll do 8 minus 7, and we'll get 1. So basically, the range of possible values is 1 is less than x, which is less than 15. Okay, and then scooting over here, we're going to add and subtract. If we subtract, 11 minus 10 is going to be 1. Total coincidence that we got 1 for both of these. And when we add, we're going to get 21. Less than x, which is less than 21. Okay, continuing on, I'm going to speed through this because this is the most recent stuff we've learned. Okay, to determine if the two triangles are congruent, we're going to do angle, side angle, because that side is included. Okay, two angles, the side right between it. Over here, you can see we only have one pair of congruent sides and one pair of congruent angles, but you can see that this side is shared. Okay, so that means we now have side angle side. So I'll write that right in. Okay. 39. I have two pairs of angles, but I also have this shared side. So I've got angle, angle, and the side that's not in between them. Since it's a non-included side, I'm putting the S out here. Continuing on. Okay. I've got here two straight lines that are intersecting, okay, which means that this is vertical angles with this. So if this is 90 degrees, this is also 90 degrees, okay. We've got two congruent sides here and two congruent sides here. And since we're dealing with opposite right angles, these are hypotenuses, okay. And if it makes up one of the sides of the right angle, it's a leg. So we have one pair of hypotenuses, we have one pair of legs, so therefore we can use HL. Continuing on. Okay, easy, side, side, side. 42, again, this right angle is vertical with this right angle. So it looks like we have hypotenuse and a pair of legs. So this is another HL situation. 43, we've got angle, angle, and the side in between them. So it looks like it's going to be angle, side, angle. 44, we've got side, side, and this third side here, which is shared. Side, side, side. We are cruising, almost done. Okay. 45, we have angle, angle, and then we have a side that's shared. Uh-oh, I only see 2 pairs of information. I know I'm going to need 3. Therefore, cannot be determined. Okay, and then for 46, okay, I have this angle here, which is a vertical angle. Now you can see I have angle, angle, and a non-included side. Okay, so scooting down, state what additional information is needed. Well, we have angle, side, angle, okay? So we know that this side is congruent because it's shared, and we know that these 2 angles are congruent because it's given. So in order to use angle, side, angle, we would need another angle on the other side of the side. So basically we would need to know that this angle is congruent to this angle. So we're gonna write that out. That's angle DEL would have to be congruent to angle DEC. Okay, continuing on. In order to use angle, angle, side, the first thing we want to know is what we already have. Well, we have a pair of angles and we have a side. Okay, now if we put the angle over here, we would have angle, side, angle, and that's not what it wants. So we must put the angle somewhere that's not here, and the only other angle available to us is here. Okay, so if we put this angle being congruent to this angle, then we have angle, angle, side. Okay, and that would mean that angle K needs to be congruent to angle E. Note that because this is not shared, it's all by itself, I don't need 3 letters. Okay, so it's convenient. I can use shorthand there. For HL, I already have the hypotenuses because the hypotenuses are opposite the right angle. Okay, which means I need a pair of legs. So you have some choice here actually. You could do DE being congruent to WV. Okay, or you could say that CE would have to be congruent to XV. Either one of these is totally valid, okay? And that second one is here, okay? Doesn't matter which leg it is as long as you have a leg in addition to the hypotenuse, okay? Angle, side, angle. Again, we want to focus on what we already know. So we have a pair of angles. We have a side. We need the angle that would make this side included. Well, that would be this angle here and this angle here. We've got shared vertices, so we've got to use all 3 letters in these angles. So we're going to use angle XVW. XVW is congruent to angle VWI. Okay, only 2 more, we're almost done. We have RQP, okay? We got angle, side, angle. We have an angle here, a side. We need to put another angle in there so that this side would be included. That's this right here. Angle Q would need to be congruent to angle C. Last but not least, side, angle, side. That would be this side over here. So YZ would have to be congruent to WV. And voila, we are done. If you have any questions, send me an email and I would be happy to help you. Okay, good luck studying. See you next week.